Good morning. I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Ministry of Aeronautical Engineering, Dundigal, Hyderabad. In this video, I would like to perform some problems on differential equations of second and higher order with constant coefficients. So we know that the solution of the differential equation of second and higher order with constant coefficients will be having two parts. One is complementary function and other one is particular integral. Already we have seen in the last class how to find the solution of the linear differential equation with constant coefficients of second and higher order. So in this video I would like to present some problems. I want to work out some problems based on the general method of finding particular integral. So the general solution will be in the form complementary function plus particular integral, where the complementary function is the general solution of the homogeneous equation f of d of y is equal to 0. And the particular integral is the particular solution of the equation f of d of y is equal to q. F of d of y is equal to 0. General solution will be the complementary function. The particular solution of f of d of y is equal to q of x is the particular integral, and the combination of these two, that is CF plus PI, will be the general solution of the equation f of d of y is equal to q of x. So to find the solution of these type of equations, we need to find the complementary function and particular integral. The complementary function is solution of f of d into y is equal to 0, and the particular integral is particular solution of f of d into y is equal to q of x, or y is equal to 1 by f of d of q of x. So on operating 1 by f of d on q of x, we will get the particular integral, and it does not contain any arbitrary constants. Already in the last video we have seen some problems. Now I would like to do more problems to get more clearance on this, and I would like to solve in the first case d square y by dx square plus a square of y is equal to tan ax. Clearly it is in the form linear differential equation with the constant coefficients of second order, and right side there is a function q of x, f of d of y is equal to q of x, right? Now to find the solution, we need to find the complementary function as well as particular integral. So the summation of these two solutions is the required solution. So first writing the given equation in operator form, that is d is d by dx or d square is d square y by dx square, on substituting d square plus a square of y is equal to tan ax. So here f of d is d square plus a square, and the auxiliary equation is in terms of m, which is an intermediate equation and which is used to find the roots of the equation and to find the complementary function. So m square, on replacing d by m, we'll get m square plus a square is equal to 0, and the roots are m is equal to plus or minus ai. So m square is equal to minus a square, or m square is equal to I square a square, where I square is equal to minus 1. So m is equal to plus or minus ia. So the roots are complex roots. So the complementary function will be in the form, the complementary function is equal to e power 0x of, because it is in the form alpha plus or minus I beta, where alpha is equal to 0 and beta is equal to a. So the solution will be e power alpha x, alpha means 0, and c1 cos beta x, that is cos ax, plus c2 sin beta x, that is sin ax. So this is the complementary function of the solution of the equation d square y by dx square plus a square y is equal to tan ax. Now to find the particular integral, we write a particular integral as 1 by d square plus a square of tan ax. Now, we have 1 by d means integral of the function, 1 by d of q of x means integral, and 1 by d minus alpha of q. Already we have seen theorem. The result is e power alpha x into integral q into e power minus alpha x dx. So, to apply 1 by d minus alpha of q format, I am writing d square plus a square is in the factor form. That is 1 by d minus ia into d plus ia of tan ax. Now, on writing in partial fractions notation, I can write 1 by 2 ia into 1 by d minus ia minus 1 by d plus ia of tan ax. So, on taking LCM, the numerator will be d plus ia minus d plus ia. So, dd gets cancelled. In the numerator, we will have 2 ia. That's why I divided with 2 ia. So, 1 by 2 ia into 1 by d minus ia minus 1 by d plus ia of tan ax. Now, to calculate this, first I consider 1 by d minus ia of tan ax, first part, 1 by d minus ia of tan ax. So, what is the formula? 1 by d minus alpha of q is equal to e power alpha x into integral q into e power minus alpha x dx. So, to apply this formula, I write 1 by d minus ia of tan ax. So, here alpha is ia. So, what will be the formula? E power iax, alpha means ia. So, e power iax into integral e power minus alpha x, e power minus iax into tan ax is q of x into dx. That is e power iax into e power minus I theta notation. That can be written as cos theta minus I sin theta. Here it is cos ax minus I sin ax into tan ax. But cos into tan. So tan means what? Sin ax by cos ax. So into cos ax. Cos gets cancelled. The first term will be sin ax. Minus I into sin ax into tan ax. Sin ax into sin ax by cos ax. That will be sin square ax by cos ax dx. Now on integrating e power iax into sin ax integration minus cos ax by a. First integral is over. Second term, so we cannot find directly. We need some manipulations. Minus I into, I can write sin square ax as 1 minus cos square ax by cos ax of dx. So on splitting this integral, first part 1 by cos ax, that is secant ax is one term. Second term minus cos square ax by cos ax, that is cos ax. So I'm writing, so I'm going to the next slide. E power iax into the first term as it is minus cos ax by a minus I into, so cos ax by cos square ax, that will be 1 by cos ax, that is secant ax. Second one, cos square ax by cos ax, that is cos ax dx. So first term as it is minus I into, so integral secant ax, the formula is 1 by a into log tan pi by 4 plus ax by 2 minus cos ax integration sin ax by a. So I can write this as minus on taking, so you can write it as a plus, I'm writing minus outside. So what I am taking out minus outside, you will get minus e power iax into, this will be cos ax plus a plus I into the term is same as it is. So just copy down. Then minus e power aix into 1 by a. 1 by a and take outside. 1 by a is a common term in all the three terms. 1 by a take outside. And write cos ax and minus sin ax as one term. Then this is cos ax minus I sin ax. A taken out already. These two terms on writing as one set. Cos ax minus I into sin ax. So that term you can write here. Plus a already taken out, you'll have I into log. So here log also, log missing, log tan pi by 4 plus ax by 2. So that is cos ax minus I sin ax can be written as e power minus iax plus I into log tan pi by 4 plus ax by 2. Log missing here. So minus e power minus iax into e power iax. e power, I can write e power IAX into e power minus IAX, that is e power. So on adding powers, minus IAX, that is e power 0, that is equal to 1. So on multiplying this and this, you will get 1. So minus 1 by a is the first term. Second term, minus e power IAX as it is, I already there multiplied by I by a into that same term log of tan pi by 4 plus ax by 2. So this is therefore 1 by d minus ia of tan ax is minus 1 by a minus I by a e power IAX into log tan pi by 4 plus ax by 2. So we have calculated 1 by d minus ia of tan ax. Similarly, we have to find 1 by d plus ia of tan ax also. So if these two are calculated, then we can substitute in the equation 1. So already 1 by d minus ia of tan ax calculated. The value is 1 by d minus I of tan ax is minus 1 by a minus I by a e power iax into log tan pi by 4 plus ax by 2. Already we have calculated. Now, to find 1 by d plus I of tan ax is just replace I by minus I in the previous result. So then 1 by d plus I of tan ax is equal to minus 1 by a constant, right, as it is. On replacing I by minus I, you will get plus I by a. And here also I is there, e power minus IAX into log tan pi by 4 plus ax by 2. Remaining terms as it is. So now, on substituting these two values in equation 1, then the particular integral is equal to, so what we will see in the next step, 1 by 2ia into, so this is the 1 by d minus ia of tan ax. This is 1 by d plus ia of tan ax. So on simplifying, minus 1 by a plus 1 by a gets cancelled. And I by a, include I by a already there. I by a log tan pi by 4 plus ax by 2. And taking outside, we will get in the first term e power iax and here e power minus iax. I am writing e power minus iax. So on taking outside, I by a log tan pi by 4 plus ax by 2 with negative sign. We will get e power iax plus e power minus iax. Or 1 by a already, a into a is there, on writing outside 1 by a square, I is there. Inside minus I log tan pi by 4 plus ax by 2. And e power iax plus e power minus iax by 2. So e power iax plus e power minus iax by 2. So what we can write it is cos ax plus I sin ax. Similarly, e power minus iax cos ax minus I sin ax by 2. So these two gets cancelled and 2 cos ax by 2. 2 cos ax by 2, that is equal to cos ax. So e power iax plus e power by ax by 2, on writing 2 here, you will get cos ax. So that is replaced by cos ax. Then minus 1 by ia also gets cancelled. I is there, here also I there. Minus 1 by a square into cos ax into log tan pi by 4 plus ax by 2. Therefore, the particular integral is minus 1 by a square of cos ax log tan pi by 4 plus ax by 2 is the particular integral of the given problem f of d into y is equal to q of x, where q of x is equal to tan ax. Now, the complete solution. How we write the complete solution? The general solution y is equal to y complementary function value plus y particular integral. So on writing both together, we'll get the complete solution. That is y is equal to c1 cos ax plus c2 sin ax minus 1 by a square. What I can write here? Cos ax of log tan pi by 4 plus ax by 2. So that is the required solution of the given problem. So here to find the particular integral, we need to go through the integration formulas, and complementary function can be obtained based on the roots of the equation. So roots are complementary roots, so the solution will be like this. I hope this is clear, and I will do some more problems because this session is completely dedicated to the problem solving. I'll do another 2 problems also, so then you'll get more clear. So this is the given problem is d square minus 5d plus 6 of y is equal to x e power 3x. So here what is f of d? I will solve this problem. Here f of d is d square minus 5d plus 6. Then what is the auxiliary equation? The auxiliary equation is f of m is equal to 0. That means what? M square minus 5m plus 6 is equal to 0. Or I can write in factor form m square minus 3m minus 2m plus 6 is equal to 0. So in adding the middle terms minus 3m minus 2m, we will get minus 5m. Minus 3m into minus 2m, 6m square. Now I'm taking out m in the first 2 terms, m into m minus 3. Minus 2 and take outside, m minus 3 will get, or I'm taking out m minus 3 common, you will get m minus 2 into m minus 3. That means what are the roots of the equation? 2 or 3 are the roots of the equation, and roots are real and distinct. So the roots are real and distinct. So what is the complementary function? Therefore, the complementary function or yc can be written as c1 e power 2x plus c2 e power 3x. So this is the complementary function of the given problem. Now find the particular integral. How to find the particular integral? So what is the particular integral in this case? The particular integral yp is equal to 1 by d square minus 5d plus 6 of, so what is the function here given? X e power 3x. So this is x e power, so I am writing it is x e power 3x. So writing in factor form 1 by d minus 2 1 by into d minus 3 of x e power 3x, because 2 and 3 are the roots of the equation. So I can write d minus 2 into d minus 3. So I'm writing in partial fraction notation 1 by d minus 3 minus 1 by d minus 2. So check the value on writing in numerator d minus 2 minus d plus 3. So 3 minus 2 1. So clearly this is the correct resolving of the partial fractions. So now consider, now what we have to consider, 1 by d minus 3 of x e power 3x. So call this is equation number 2. And original one, the complementary function, call this is equation 1, and it is equation 2. So how you can write, what is the formula? 1 by d minus alpha of q. 1 by d minus alpha of q is e power alpha x integral q e power minus alpha x dx. So here 1 by d minus alpha 3. So e power 3x into x into e power 3x. This is q, and e power minus 3x of dx. So then what you will get? E power 3x. So e power 3x into e power minus 3x. E power 0 1, that is x of dx. So what you will get is x square by 2 e power 3x. That is the first term. 1 by d minus 3 of x into e power 3x. Similarly, 1 by d minus 2 of x e power 3x. So how you will write e power 2x, 1 by d minus alpha. So alpha is equal to 2. So e power 2x into integral. What is q? X e power 3x. And what is e power minus 2x is another factor of dx. So then what you can write? E power 2x into integral x e power x of dx. But what is the formula for integral x e power x dx? We can write e power x into x minus 1. So I can substitute directly. So e power 2x into e power x into x minus 1. That means what? The final value is e power 3x of x minus 1. So the first value 1 by d minus 3 of x e power 3x is this is. 1 by d minus 2 of x e power 3x is this is. So on substituting these two values in equation number 2, now on substituting in equation 2, yp is equal to 1 by d minus 3 of e power x e power 3x, that is x square by 2 e power 3x minus the second term. What will be the second term? E power 3x into x minus 1. E power 3x of x minus 1, or e power 3x on taking outside x square by 2 minus of x plus 1. So this will be the particular integral of the given problem. Therefore, the complete solution y is equal to y complementary function plus y particular integral. That is y is equal to, so what are the roots? 2, 3 roots. So function, complementary function will be c1 e power 2x plus c2 e power 3x plus, what is yp here? E power 3x of x square by 2 minus x plus 1. Right? Yp is, just you see here, yp is this is. So this is yc, complementary function, e power 2x, e power 3x and the arbitrary constants. And here yp on solving, this is the value x square by 2 e power 3x, and the second part is e power 3x into x minus 1. So on writing in one equation 2, we'll get 1 by x square by 2 e power 3x minus, I'll show this, minus e power 3x is common in both the terms. So yp is equal to e power 3x on taking outside x square by 2 minus x plus 1. So the complete solution yc plus yp. So this is the methodology to solve the second and higher order differential equation with constant coefficients. And I will see one more example also here. Already we have done d square plus a square of y is equal to tan ax. So similarly, we need to perform, you have to solve d square plus a square of y is equal to secant ax. So this also will solve, that will be the more confidence on this subject. So here, what is f of d here? So already it is in operator form. The original equation is d square y by dx square plus a square y is equal to secant ax. This is the original equation. On writing in operator form, the problem will be d square plus a square of y is equal to secant ax. So already given in the operator form. So the auxiliary equation, what is the auxiliary equation? F of m is equal to 0. That is m square plus a square is equal to 0. So m square is equal to minus a square or I square a square. So m is equal to plus or minus ia. So the roots are complex roots. The complementary function are yc in the form c1 cos ax plus c2 sin bx of e power 0x. That you can neglect because e power 0x is 1. c1 cos ax plus c2 sin ax. This is the c1a. This is equation number 1. This is the part 1 solution, complementary function. Now to find the particular integral. So how to find yp? Yp is equal to 1 by d square plus a square of secant ax. So that it is 1 by d square plus a square of secant ax. So to operate secant ax with 1 by d square plus a square, you cannot do directly. So write in factor form, that is 1 by d minus ia, 1 by d plus ia of secant ax, as we have seen in the previous problem. Previous problem. So how I can write the factor notation or the partial fractions? So 1 by d minus ia of 1 by d plus ia of secant ax. So this I can write it as 1 by d minus ia minus 1 by d plus ia of secant ax, and what we have to multiply here? So here you can, the numerator part will be d plus ia minus d plus ia. That means what? 2ia will get in the numerator. So to cancel out 2ia, I am multiplying with 2ia. Am I right? Now the equation satisfies the expression 1 by d minus 2ia, 1 by 2ia of 1 by d minus ia of secant ax minus 1 by d plus a of secant ax, and call this is equation number 2. Now what we have to consider? Now consider 1 by d minus ia of secant ax. This is looks like 1 by d minus alpha of q. So formula is e power alpha x integral q into e power minus alpha x into dx. So alpha is ia, so e power iax into q is secant ax into e power minus alpha x, that is e power minus iax into dx. But what is e power minus iax? What I can write? That is cos ax minus I sin ax of secant ax of dx. Now it can be written as e power iax into integral cos into secant. Cos into secant. Cos secant are reciprocals. Cos secant are reciprocals. Cos into 1 by cos, that is 1. Second one, 1 minus I into sin by cos. This is equal to tan ax of dx. So multiplying with secant ax, cos into secant 1 minus I into sin by cos, that is equal to tan ax. So what is the integration? Integral 1 dx. The first term is x. Second term I constant. And this is integral tan ax dx. What is integral tan ax dx? So I can write it as log secant ax by a. 1 by a log secant ax, or I by a log secant ax. This is the integral tan ax dx formula. So what this is? 1 by d minus ia of secant ax. Now replace I by minus I. Then what we will get? 1 by d plus ia of secant ax. And replacing I by minus I, we will get 1 by d plus ia of secant ax. We need 1 by d plus ia also. So just on replacing, you need not to do once again the same procedure. Just replace I for minus I, that is 1 by d plus ia of secant ax, that is e power minus iax into, so what is the solution of x into, this is the final solution. So final solution, this is x minus I place low on writing minus I, you get plus I by a of log secant ax. This is the part 2 solution of the equation number 2. So 1 by d minus I of secant ax already we reached. Similarly 1 by d plus I of secant ax also reached. So the substituting these two in equation number 2, equation 2, yp is equal to 2 implies yp is equal to 1 by 2 ia, and what is the first term? E power iax into x minus I by a log secant ax. I hope this is right. X minus I by a log secant ax. X minus I by a log secant ax minus e power minus iax. What is the second value? So I will show here. E power minus iax into x plus I by a. X plus I by a log of secant ax. So this is 1 by 2 ia into, So I'm taking out x e power iax, x e power minus iax. I'm taking out x, you'll get e power iax minus e power minus iax. So from the first and third terms. Similarly, from second and fourth terms, I by a log secant ax is common. So minus also you can take out common, minus I by a log of secant ax on taking outside. So what you will get in the first step, e power iax and minus I by a. So here also I by a log secant ax gone out. You will get minus e power minus iax. So this is equal to 1 by 2 ia into x into, what is this value? E power iax cos ax plus I sin ax minus cos ax minus I sin ax, and this will be plus, and this is equal to I sin ax. I'm simplifying the term in the bracket, cos ax plus I sin ax minus, this is cos ax minus I sin ax. So minus cos ax plus I sin ax, this is 2I sin ax minus I by a. What is I by a? Log secant ax. So this will be the 2 e power iax minus. So minus on taking outside here, minus I by a, you'll get the plus sign here. And this is equal to 2 cos ax. This is 2 cos ax. So on simplifying, 2ia, 2i gets cancelled. 2i gets cancelled. You'll get x by a sin ax first term. And minus I by 2 also cancel, I cancel, 1 by a square. So I also will get cancelled. So here you'll get 1 by a square of cos ax into log secant ax. So this is entire term is called the particular integral of the given differential equation. So already we reached yc, and already we got yp as x by a sin ax minus 1 by a square into cos ax into log secant ax. So therefore the complete solution, what will be the complete solution? Y is equal to yc plus yp is the complete solution. On adding both two, we'll get the required solution of the given differential equation. So these are the problems which were worked out for the benefit of the students. And in the next class, this is the very lengthy method. This to find the particular integral, you need to cross many integrations and many formulas. But based on the given function, we have shorter methods also to find the particular integral, and that will be discussed in the next video. So these are the general type. This is the convention type. Based on the formula, we found the particular integrals. In the next class, we see how to calculate the shorter methods to find the particular integral. That we will see in the next video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.